This video is going to look at current, potential difference and resistance calculations when components are in series and in parallel. For this, we need to know a bit of prior knowledge, and this includes the units for the following quantities. So potential difference, we should know at this point the unit of potential difference, called voltage, is volts. And current is, that's right, it's amps, and resistance is ohms. Now, for the following video, we also need to know a few equations. We have to be familiar with the fact that potential difference is equal to current times resistance, and we'll be rearranging this equation in this video today. We also need to be aware of how to calculate total resistance in series and in parallel. So in series, the resistance total in series is equal to all of the resistors. So resistor 1 plus resistor 2 plus resistor 3, etc. when they are in series. When they are in parallel, it's a little bit different because the total is 1 divided by the resistance total when we have 1 divided by the first resistor plus 1 divided by the second resistor plus 1 divided by the third resistor. Now at GCSE, what we have to know is that in a parallel circuit, when we have resistors in parallel, that the resistance is always lower than the lowest resistor. So if the lowest resistor we had was 2 ohms, we will know the total resistance is going to be below 2 ohms. And that's because, remember, we have that relationship of when we have a high resistance, we have a low current, and vice versa. So this video, we're going to look at some circuits and hopefully be able to calculate the current, potential difference, and resistance. So in this circuit, you can see it's a parallel circuit with 2 loops. The loops here, we've got a loop here and we've got a loop here. And then this first loop here, we've got 1 bulb. And in the second loop, we've got 2 bulbs. This first loop, we know we have a current of 0.2 amps and it contains 1 bulb. This second loop, we have got 2 bulbs, and so we have got double the resistance. And because we have got double the resistance, we're going to have to half the current. So A1 is going to be 0.1 amps. A2 is the total of both loops in this circuit, so 0.2 plus 0.1. So that's going to be 0.3 amps. For our potential difference here, potential difference we know in a parallel circuit, each loop is equal to the total potential difference. So potential difference of this cell is 3 volts. So this loop here will also need to have potential difference of 3 volts, which is why V1 is going to be 3 volts. Now in our second loop here, this loop here, we've also got to have potential difference of 3 volts, but we've got 2 bulbs in this one, so we half each one. So 3 divided by 2 is 1.5, so each one is 1.5. And then when we total V2 and V3, it will equal V1. How did you get on for that one? This next circuit, you see, is a series circuit. Now this series circuit, you have to know that in a series circuit, current is the same throughout, so it won't change. So we know from this ammeter here that the current is 3 amps. So A1 is also going to be 3 amps, and so is A2. Now in a series circuit, all the components' potential difference equals our total potential difference because it's shared amongst the components. So our total is 9 volts. So the potential difference of our two resistors here would also equal 9 volts. So we know it should equal 9. One resistor there, we know potential difference of 3. So 9 take away 3 is equal to 6. So V1 is 6 volts. This is 6 volts, that's 3 volts. 6 plus 3 is equal to 9. Now our resistor here, we need to know and be familiar with the calculation that we just looked at. And that is that potential difference is equal to current times resistance. Now we want to calculate resistance, so we have to rearrange that. So it's potential difference divided by current. So for R1, what do we know? Well, we know the potential difference is 3 volts, and the current here is 3 amps. So it's 3 divided by 3, which gives us a total of 1 ohm. So again, pause the video, see if you can crack on with this circuit, try and find A1, V1, V2, V3 and V4. Alright, so let's have a little look at this. So we know it's a series circuit, so current remains the same, so A1 must be 2 amps because that ammeter there says it's 2 amps. Now we want to work out V1, Here, that's our total resistance. So we know at the minute, the knowledge that we have, that we're going to have to use to do this, is that V1 is equal to V2 plus V3 plus V4. So how do we work out V4, V3 and V2? So for this one here, we're going to have to, again, use the calculation of V equals current times resistance. So our current is 2, and our resistance here and our resistor there is 3. In V3, the current is 2, and the resistance is 2. In V2, the current is 2, and the resistance is 5. So for V4, it's 2 times 3, which is going to be 6 volts. For V3, it's 2 times 2, which is going to be 4 volts, sorry. And V2 is 2 times 5, which is 10 volts. And as we said, that V1 is all of these added together. It's a total 10 plus 4 plus 6 is equal to 20 volts. Our next circuit, again, pause it, have a go, see if you can work out what to do. So this is a parallel circuit. So with our parallel circuit, we've got to know a couple of things here. So what do we know here? Well, we know our total potential difference here is 9 volts. So if that's 9 volts, V1 is also going to be 9 volts because it's on that single loop, which means this loop here must also have a total of 9 volts in this section. We know we've got our resistor here that's worth 4 volts, which means to do the calculation, total is 9, take away 4 is equal to 5 volts. So now we want to work out the current. So the current here going through is, we've got a node, we've got a junction here. So this 2 amps will be flowing through here, and it will join up here with this one. So A1 is going to be higher than 2 amps. We know that. But we need to work out the current here. So to do that, again, we need to use the calculation that V equals current times resistance, but we need to rearrange it now because we want to work out current. So current equals voltage divided by resistance. So for this bulb in the middle here, in the central loop, our potential difference for V1 is 9, and we divide that by our resistance, which is going to be 3, okay, which gives us 3 amps. Just highlight that in green. So A1 here is going to be 3 amps. So then we can work out the resistance of our bulb and our resistor. So our bulb has got V2 potential difference, so that's going to be 5 volts. So just like before, using this calculation over here, we want to work out the resistance. So the resistance is going to be equal to the potential difference divided by the current. So the potential difference for the bulb is going to be 2, and we can then, sorry, it's not, is it? Apologies. The bulb potential difference is 5, but the current is 2. 5 divided by 2 is 2.5 ohms, and for our resistor, the potential difference is 4, and we divide that by 2 amps, which is equal to 2 ohms. How did you get on with that one? For our next circuit, we can see it is a parallel circuit, and so we can see straight away in a parallel circuit that the potential difference is the same on each loop. We've got one potential difference that is given to us, that's 8 volts. So each loop must have a total of 8 volts here. As there's only one component on each of those are going to be 8 volts. So V2 is 8 volts, V3 is 8 volts, and the total potential difference will also be 8 volts. Now, when we look at this, we then have to work out our current. As we said, the current we know at the beginning and at the end is going to be 12 amps. So A1 plus A3 plus 3 amps must equal 12. So we need to know then the current for A1. So we need to use and think about the calculation V equals IR again. We want to work out the current, so again we need to rearrange it, so it's current equals potential difference divided by resistance. So for A1, our potential difference is 8, our resistance is 2. 8 divided by 2 is equal to 4 amps. So A1 is 4 amps. So we have 4 amps at this point here. Now, following that, we should then be able to work out A3, because, as we said, each of these must equal 12 amps. So what do we know at the minute? Well, we know that A1 is 4 amps, and then the second loop is 3 amps. So 4 plus 3 is equal to 7. All right, and it must equal 12 in total. So 12 take away 7 is equal to 5 amps. 4 amps, 3 amps, 5 amps equals 12 amps. A2 is going to be the total of these two currents. So we've got 3 amps here, and A3 is 5 amps. So we can have 5 plus 3, which is equal to 8 amps. And then we can work out our resistance for our resistor here. And again, we use the calculation. Let's try and do it all the same colour. The voltage is equal to current times resistance. Now we want to work out resistance. It's R1, so resistance is equal to potential difference divided by current. Our potential difference is V2, which is going to be 8 volts. Divide that by our current, which is 3 amps. So on a calculator, that'll be 2.67, or you can round it up to 2.7 ohms. Again, if any of that is confusing, pause it, replay the video again, and it's just practice using the calculation. So next we have a few more of our components that we've got to be able to calculate. So we know it's a parallel circuit, so V1 V2 and V3 are going to be the same. So once we've found one, we know what they all are. And we know that we've got 8 amps here at the start, and at the end is going to be the same current. So we know straight away, we can put that there, that A1 is going to be 8 amps, which means the current flowing through it at this node here, that 3 amps, all right, 3 amps plus A2 must equal 8 amps. So when we look at this, so we've got 8, take away 3, which is equal to 5 amps. And this area here, the current is going to be the same. We treat it as a series circuit. So A3 is also going to be 5 amps. Now, once we have that information, we can then look at V3. V3, we know the resistance here. We know the resistance here. And now we know the current. So again, just a reminder, it doesn't hurt having lots of practice, that the calculation V equals IR. All right, so for V3, what is our current? Well, it's going to be A2 and A3. It's the same. That's 5. And we need to times that by our resistance, which is going to be 4, which is going to be 20 volts. And it's a parallel circuit, so we know that V2 and V1 are also going to be 20 volts. We can then look at our resistors. Here for R1, we're using this calculation again that we might want to rearrange. That the resistance equals potential difference divided by current. So our potential difference here is going to be 20. We divide that by our current, which is going to be 3. So 20 divided by 3 on your calculator comes out at around about 6.666. Just doing it now. 7 ohms. So you want to double check that. And then we want our total. Now, in our total resistance here, remember our total resistance from the start of the video is going to be 1 over resistor 1 plus 1 over resistor 2. So our total resistance is going to be equal to 1 over resistor 1, which we've just worked out as 6.66667 plus 1 divided by 4. Okay, so once we've got that answer, all right, we then, well, that answer there is 1 divided by that answer of that equation. And if we just put that into a calculator, 1 divided in brackets by 1 divided by 6.666667 plus 1 divided by 4 close brackets, we should get an answer of 2.5 ohms. So that's our total resistance in this circuit. I remember, like I said at the beginning of the video, our total resistance in a parallel circuit will always be lower than our smallest resistor. This resistor here is 6.67 ohms. This one is 4. So that's our lowest resistor. And our total is 2.5, which of course is lower than 4. Now, in our final circuit we're going to look at, again, pause the video, take a little look and see what you can work out first about what we know. So, we know it's a parallel circuit, and in each loop, the total potential difference must equal the total potential difference here. So, we know in that loop there, we've got 5 volts and 3 volts. So 5 plus 3 is equal to 8 volts, and we've got V2, which is also going to be equal to 8 volts. We can then work out our resistance for resistor 1. Remember, resistance, we use the equation, so resistance is equal to potential difference divided by current. So potential difference divided by current for R1, we've got 5 volts divided by 4, which gives us a resistance of, let's do it in the calculator here, 1.25 ohms. And for resistor 2, we have 3 volts again divided by 4 amps, and that's 0.75 ohms. So then we can look at our current. So what do we know about the current? Well, we should know that A1 and A3 are going to be the same. And A1 is going to be, or A3 is going to be equal to 4 amps plus A2. So now we need to work out A2. So to work out current, we have to use that magic equation again, that potential difference is equal to current times resistance. We need to rearrange that to work out current, which is going to be potential difference divided by resistance. So for A2, our potential difference is going to be V2, which is going to be 8. A2 is going to be 8 volts. We need to divide that by the current. What we've got here is that circuit. Again, we've got a parallel circuit here. And just a reminder, like we said before, it's R1 divided by our resistance total is equal to, in this occasion here, it's going to be 1 divided by 3 plus 1 divided by 2. So that's how we do the calculation there. And our answer, if we are correct, must be equal to our lowest resistor in this scenario. And then when we do that, we can then have our answer. So it's 8 volts divided by the resistance here. So 1 divided by RT, which is equal to 1 divided by 3 plus 1 divided by 2. And when that comes out, that will come out at 1.2. So it's 8 divided by 1.2. Again, you can check this on the calculator as well. Check I've done it correct, which is 6.67 amps. And if that is, done it in the wrong colour there, haven't I? 6.67 amps. A1 is going to be A2 plus 4 amps. So 6.67 plus 4, 10.6 amps. A3 is going to be the same as A1. So that is also 10.6 amps. So go through these videos again if you're not quite sure any of these circuits. Pause them, have another go, and check you've done the answers correctly. I hope that's helped you work out how to calculate current, potential difference and resistance when components are in series and in parallel. If it has, leave a comment.